When you studied parent functions in Lesson 5.1, you already reviewed with Mrs. Milburn about domain and range and relations and functions and the vertical line test. In this lesson, the focus is going to be more on starting with an equation or its graph. What is the domain? What is the range? Let's look at a few examples. For instance, basically y equals x to the third power. One of the easiest things to do is draw a picture. So if you have remembered that parent function, you know that the graph, or from our study of polynomials, you know that the graph looks something like this. Well, the domain, that's how far do the x's spread? How low do they go? How high do they go? Well, the x's keep going forever in the negative direction. So we could use interval notation and say that the domain is from negative infinity up to, the x's are going to be spreading out this way very slowly, but the x's will keep moving out to the right, positive infinity. Sometimes this is written as all real numbers, or shorthand, all reals. Even more shorthand, this is sometimes written with a capital R that looks a little strange. The range? Well, the range is the spread of y values. How low do the y values go? How high do the y values go? And once again, that would be from negative infinity to positive infinity, or all real numbers. Okay, for this next example, once again, if you can draw the picture, it's going to make it so much simpler. So hoping you remember that parent graph. The original square root function, the original parent, would be something like this. But that plus 3 that's in with the x means that the whole graph is going to get shifted 3 spaces to the left. So our parent function got transformed into this, and that's the function for which we determine the domain and range. So how low do the x's go? What is the lowest x value that we have? Well, it looks like it's a -3, and we do have an endpoint right there, solid dot on -3. So we could use interval notation, and they go on forever to the right. The range, how low do the y values go, and how high? Well, the y values don't go any lower than 0. And although they are climbing very slowly, they are climbing, and they will go on forever. Our next example is very practical. It has that unusual graph. This is also known as the integer function. And from 0 to 1, the answer is 0. And if we put in anything from 1 up to 2, the answer is just 1. And if we put in anything from 2 up to 3, the answer is just 2. They often call it the post office function because you can't buy a part of a stamp. You have to have enough money for one stamp in order to get the stamp. You have to have enough money for 2 stamps in order to get 2 stamps. Anything in between, and you don't get any more. So, but we're interested in domain and range. So the domain, and this does continue going this way. That doesn't fit the pattern for stamps. We're not going to get negative stamps, but the general parent function does have negative parts. So we will eventually get every x value. I mean, we have a hole right here, but it's taken care of. It's covered right there. So this is going to be all reals. Or we could say negative infinity to positive infinity. The range is not going to be all reals. There are gaps here in between. We could say that the range is all integers, which we are not going to try to put in interval notation. Even relations that aren't functions still have a domain and range. We'll get familiar with equations like this soon. This is actually the graph of a circle centered at the origin with a radius of 5. So the domain is going to be the spread of the x values. How low did they go? How high did they go? And they go from -5 to +5. The range. How about the y values? Going from bottom to top, lowest to highest, would again be -5 to +5. Do you remember what this graph looks like? It's actually a vertical line. Definitely does not pass the vertical line test. Here it's 6. It still has a domain and range. For the domain, the x's have one and only value, just 6, which you could write like this in interval notation. Just 6. Starts and stops right there. The range. Now the range is how low do the y's go, how high do the y's go, and the range goes from negative infinity to positive infinity. Would you please go do a really short U-try on domain and range?